I hope I am audible to all of you. I hope I am audible to all of you. Okay, we shall first have a quick review of the data flow modeling, and then we shall go for the example of the data flow modeling. Is that all right? Be quick with the response in the chat box. Is it not easily available? If not, then okay, it's all right. Oral responses. Those who are working from laptop, so they can immediately give the response. So the second type of modeling is the data flow modeling. Second model is the data flow modeling. In the behavioral modeling, it is possible to use the higher level language like statements, particularly those particular statements. They are the if then else statement, case statement. Then the loops. In the loops, you can have for loop or you can have while loop. Such statements can be used in behavioral modeling, whereas in the data flow modeling, such statements cannot be used. The characteristics of the behavioral modeling is that it uses process statement in the architecture. Okay, whereas you will find in the data flow modeling there is no process statement, and hence all the statement in the data flow modeling they are concurrent, that is they are executed simultaneously. So data flow model specifies the functionality of entity without explicitly specifying its structure. Then this functionality shows the flow of information to entity expressed primarily using concurrent signal assignment statements and block statements. Okay, so the statements that are primarily used in this, they are the concurrent signal assignment statements. So the point to be noted that the data flow modeling, most of the statements, they will be the concurrent signal assignment statement. Okay. So already you know how is the form, how is the central syntax of the concurrent signal assignment statement. It is the less than sign and equal to. This is the uh, this is in contrast to the behavioral style of modeling, which we have discussed earlier, in which the functionality of the entity is expressed using procedural type. That is the statement which are like in the higher level languages. Okay? And they are executed sequentially. In the behavioral modeling, they are executed sequentially. But here, they are this particular statement, all these statements, the data flow modeling, they are executed concurrently, that is simultaneously. So one of the primary mechanisms for data flow for modeling of the data flow behavior of entity is by using the concurrent signal assignment statement. So, an example data flow model is two input OR gate. Okay, so this is shown in this particular diagram. There are two inputs A and B, and there is one output that is Z. So OR2 is the name of the entity. E, that is the syntax. So the port we specify input and output. So A and B are input, whereas it is of type bit input, so in keyword, and you have Z output. So that is why out here, and it is of type bit. Then here you have a single statement in the architecture. Okay, so architecture OR2 of OR2E begin Z. So what is Z is assigned? This is signal assignment statement. So Z is assigned A or B after 9 seconds and end of this architecture body. Okay, so this is the data flow model. Okay, so this particular short program is for the data flow kind of model. Okay. You can see other examples. Now this is the full adder. Okay, so I gave this assignment to you already. This particular program is there. We discussed earlier. So if you compare this particular program with the program that we have written for the behavioral modeling, so what is the change? Absolutely, there is no change. The entity statement. Okay, so the entity statement is the same. Whereas there is a change in the architecture statement. So in the architecture statement, uh, here we are using uh, two signal assignment statements. Some is assigned, some which is the output is assigned A XOR B XOR C in, and that is of course 15 nanosecond. Okay, so if you do not write this 15 nanosecond, then immediately some will be assigned with C in. Sorry, this particular whole expression A exclusive or B exclusive or C in, whereas C out is assigned A and B or B and C in or C in and A. So that is assigned after 10 nanoseconds. Okay. So here this is the architecture body for the full adder. Okay. So only two statements are there. The point to be noted here is that it is not that the sum statement, this particular first statement is executed first and then the second statement is executed. It is not like that. Okay. Both the statements are executed or simulated, you can say, simultaneously. Okay. So it does not matter whether you write cout statement first, cout equal to this statement first, or if you write some statement first. Okay, so it does not matter which statement you are writing first. Another point to be noted is that there is no process statement in this. Okay, so that is why this particular statement sum is equal to and cout is equal to statement. They are the concurrent signal assignment statement. Okay. I hope you understood this particular difference between the program for the full adder in behavioral modeling and in the data flow modeling. Then this is the another program. This program is for the this particular program A is equal to B and Z is equal to A. Okay, so finally what you have is this is the part of the program. So the purpose of the program may not be doing some operation. It is just to show what are you going to do in this. You are assigning the value of B to A, and you are assigning you are assigning signal B to A, and you are assigning the signal Z to A. Okay, so but this particular statement they are executed simultaneously. So it absolutely does not matter whether you write this particular statement anywhere. Okay, so here there is no problem. Okay, but uh, here this particular part is the behavioral modeling because here the process statement comes here. Okay, so because the process statement comes here, so this is the behavioral modeling. Okay. So here you are writing, you are assigning a this statement is executed first. That is, A is assigned B and then Z is assigned A. Okay. So the upper part, the sequence matters, whereas in the lower part of the sequence does not matter because the statements they are executed concurrently. Okay. So that is only to specify the concurrent versus sequential signal assignment statement. Okay. Then the signal assignment statement they can be conditional signal assignment statement. Okay. So the general format of this particular signal assignment statement is that the target signal. Okay. So most of the time this signal is some output signal, but always it need not be the output signal. It may be some intermediate signal. You can declare some signal variables in the architecture body, that is before the architecture body starts, and to that particular signal you can assign some other signal, maybe input signal or some intermediate signal. Okay. Then that assignment it can be conditional assignment. Okay, so if the condition is true, then the another signal will be or it will be you need to specify that particular signal. Okay, otherwise you may assign some other signal. Okay, so we can see some example of this. So, this is typically the example for the multiplexer, four input multiplexer. So probably in the four input multiplexer, you will be using this. Z is assigned in 0 after 10 nanosecond when S0 is equal to 0 and S1 is equal to 0. Or it will be assigned in 1 after 10 nanosecond when S0 is equal to 1 and S1 is equal to 0, or else in2 will be assigned after Z will be assigned in2 after 10 nanosecond when S1 is equal to S0 is equal to 0 and S1 is equal to 1, else in3 is assigned to Z after 10 nanosecond. Okay, so this is the part of the program. So from this, can you write a program for a multiplexer? Can you write a program for multiplexer? Yes, students. Using data flow modeling. A program, complete VHDL program for multiplexer. I hope I am audible. Why there is no response in the class of 44?
Yes, sir. We will try, sir.
Huh? Just try. I am going to give you 5 minutes. The multiplexer is 4:1 multiplexer. Okay. Write a VHDL program using data flow modeling for 4:1 multiplexer. 4:1 multiplexer. Okay. So the important statement which will come in the architecture body is there on the screen. The statement is there on the screen. So the other statement you need to write. So in the beginning, you will be writing entity statement, and after that, you will write. After that, you will write the architecture statement. I hope all of you are working. As soon as you are done, send a snap in the Telegram group. Send the snap of your program in the Telegram group. If you are working from mobile, then sending snap will be easy. Are you ready with the program? Anybody ready with the program? You can you can start your back camera and you can show the program. So you are ready. Just ask me so that only one student will be doing it. You can start your back camera. On the mobile, there is a circle. So with that, I have started my back camera. I'm sitting in one class. Anybody is going to show the result? Let me know so that everyone can focus on that particular student. Yes, Chandrakant, Aniket, done with the program?
Sir,
Yes.
so trying, sir. Trying. Wait, sir.
I hope all of you are working. First statement is entity. In that you have port statement. In the port there will be two inputs and there will be four inputs. The four inputs they are nothing but in 0, in 1, in 2, in 3. And in addition to this, again, two more inputs, that is select lines S1 and S0. So totally there will be 6 inputs and only one output, and that one output is the Z output. Okay, so these will be the four inputs, and there will be one output Z. If anyone is ready, then let me know. You can start your back camera, or if you are on the laptop, you may present your screen. If you are working on the laptop, you may present your screen. Is anyone ready?
Hello, sir.
Hello, yes.
Sir, Telegram group, sir.
You posted on Telegram group. Nikita has posted this. Is it properly visible? So entity multiplexer 4 is to 1 is 4 S0 S1 in bit Z. Uh, Nikita, you forgot in 0, in 1, in 2, in 3, in 4. Unmute yourself, Nikita.
Yes, sir.
You forgot 4 inputs in 0, in 1, in 2, in 3.
Okay, sir.
So that also should have been there along with the S0 and S1. Okay. The
Yes.
rest is all right. Okay. Z out date. Okay. So that is correct. Architecture data flow of multiplexer 4 is to 1 is, so that is correct. Variable, so here these variables, it should not be variables, so those are inputs in 4 is to 1 multiplexer. In 4 is to 1 multiplexer, so 4 inputs are there, so there is no need of variable over there. Okay. And even if variable are to be defined, then variables they should be before begin, Nikita, and all other students also. So if you are defining signals, so there is no question of variables in the data flow modeling. You should use signals. In the data flow modeling, you must use signals. Variables you can use in behavioral modeling. Note this point in your notebook. Variables used in which modeling? Behavioral modeling. Whereas,
Behavioral.
yeah, in the data flow, you should use signals. Okay. Then now considering this as in 0, in 1, in 2, in 3, they are inputs. So now rest of the thing is correct. Okay. So it was already there on the screen. Okay. So that is Z is assigned in 0 after 10 nanosecond when S0 is 0 and S1 is 0. Okay. So rest of the thing is all right. Okay. Uh, Let us go for the program which has been posted by Sonali also has posted the program, but now it is so how should I show this now? Okay, S0, S1, S2, S3, S2, S3 is not required, Sonali. Are you there? Unmute yourself. S2, S3 is not required. Hmm? And no, that is not, your program has certain problems, Sonali. Okay. You check out with the program of Nikita. It is available there. Okay. Let us see what Chandrakant has done. Multiplexer. Then here is, you can pin me so that your screen will be visible to you. That way I am trying to focus it properly. Is it visible? Chandrakant, this is your program. Unmute yourself.
Yeah, yes, sir.
So entity mux 4 is to 1 each.
One.
Then
One.
that is correct. Then below
Three.
that,
Three down.
plus in yesterday logic vector,
Three down.
that is also correct. Then this what? Y or Y? Okay, Y out yesterday
Out. Logic.
logic. Okay.
Yes.
Okay. Then you have what is
Architecture.
architecture?
Architecture data.
So complete architecture should be written. It is a keyword. Huh? That
Yes, sir.
abbreviation is not expected. Data flow of 4 is to 1 multiplexer is begin. So begin
Select
Y.
output. Two select output.
Okay, you are used with select.
Yes.
With S select. Okay, select option you are used. Okay. So
Yes,
that
sir.
is also possible. Okay, with yes select. Then
In first.
yes is yes is a vector of 2 bits. Huh? So
Yes, sir.
y assign y I0 when so there you
Sir,
should
0 0 is there. 0 0 is
uh,
sir there. I missed 1 0.
the first line you are written only 0. So that should have been
Yes, sir. 0 0 is there.
0 0. Rest of the thing is correct. Okay. So I1 when 0 1, I2
0
when
1.
1, I3 when others.
Others.
So you have used this particular with as select. Okay, so select statement you are using.
Yes, sir.
So that is so you should know which particular statements you can use in case of the in case of the data flow modeling. Okay, so we shall quickly come to the statement which you can use for the data flow modeling.
Sir,
So you can you can pin back the screen which where the presentation is there. My mobile also I'm seeing it back. I think I have stopped the presentation. That is why it is not visible. Is the slide visible now? Okay. Is it visible?
hello, sir.
Huh? Hello? Is the
Yes,
slide
sir.
visible?
Yes, sir. Slide is visible.
Okay. Any problem?
Sir, what is the meaning of in entity statement? We write 3 down 2 to 0 or 1 down 2 to 0. What is it meaning, sir?
What is meaning of?
Sir, in the program of 4:1 multiplexer,
Huh?
in the entity statement, we write 3 down 2 to 0 in entity statement.
In entity statement, we write 3 down to 0. So that is a vector. Okay,
Sir,
3
what
down
is
to
it
0.
meaning?
It is a vector. In the array, how do we declare array? We declare array int a of 10. Okay. So how many elements we create there? 10 elements. So those elements take the value from 0 to 9, isn't it?
Yes.
Okay. A0, A1, A2, A3 up to A9. So 9 elements are created there. So here it is the vector declaration. Vector is similar to array. Vector is similar to array. So 3 down to 0 means what? It will take the values 3, 2, then 1, 0. Okay, so it is a vector with 4 elements. So there are four elements in that particular vector. So vector is similar to array. So if you are declaring it with I, then it will be I0, I1, I2, and I3. So you can declare it like this 0 to 3, or you can declare it like 3 down to 0. So it is one and the same thing. Is that clear?
Yes, sir.
Is that clear? So it is just like declaring the array. Okay. So it is just like declaring the array. In array, what we do, we only specify the maximum element required. Okay. Whereas here we specify the range. We specify the range 0 to 3 or 3 down to 0. Okay. So this we do while declaration also, or this we in the similar fashion we write in the for loop also or while loop also. Okay, so it is either 2 or it is down to, right? Now quickly let us quickly go through the statement which we can use in the signal assignment statement. Okay, so the selected signals assignment statement. So this is the statement just now. I think Chandrakant used this particular statement. So with expression select, and here you can use the target signal, and you can assign the waveform element which you want to assign, and then you can write when choices. Okay, so this particular choices has to match with this particular expression. Okay, so I will just take a pointer here. Okay, so these particular choices, they should match with what? It should match with this particular expression. So what will happen? Any one of these particular choices will match with this expression. So for whichever the clause, if match occurs, then in that case, that particular waveform element, okay, so that will be assigned to this particular target element. Okay, so this is the target element. It will be assigned with the waveform element where the match occurs. So let us say here the match occurs, then in that case, the match of this with this occur expression with expression select occurs, then this waveform element will be assigned to the target element. Okay, so for example uh, here this opcode. Okay, so with opcode, so this is the expression. Okay, so it will match with either add, or it will match with subtract, or it will match with multiply, or it will match with divide. So let us say it matches with multiply. Okay, so this opcode, let us say, matches with multiply, then in that case what will happen? Z will be assigned. What Z is assigned? Z is assigned A into B. Okay, so this will be assigned to Z. If instead of multiply, if this upward matches with the second one, that is subtract, then in that case Z would have assigned this particular A minus B. Okay, so I hope you understood, or you understood this particular selected signal assignment statement. Okay, so what this is called? Selected signal assignment statement. Okay, so signal, there are different forms of the signal assignment statement. So this is the selected signal assignment statement. Okay, so this is again another example of the selected signal assignment statement, but now this is the versus, I think here it is in the process. Okay, so this is a process statement is used here, so that means here this is the behavioral modeling. Okay, whereas here is the selected signal assignment statement. Okay, So if there is a case statement, okay, so if there is a case statement, then the case statement in the behavioral modeling, so it can be replaced with the selected signal assignment statement. Okay, so this point you can note. Okay, so when you are uh, converting a VHDL program which is there in the behavioral modeling where you have used the case statement. So case statement can be replaced with the selected signal assignment statement because you cannot use case statement in the data flow modeling. Okay. Then there is a block statement. So a block statement is a concurrent statement. It can be used for three major purposes. The first purpose is to disable signal drivers by using guards. The second one is to limit the signal scope, and the third one is to represent a portion of uh, a design. That means you can make blocks, or you can divide your circuit into the different blocks. Okay, and you can specify that this is this particular block or this is another block. Then the signal, so you need not have to declare the signal. So usually you declare signal in the beginning in the architecture, but if those signals are not required throughout that particular architecture, then it is good. You can see it is a good practice that in between you define a block and you can limit the scope of those particular signals to that particular block only, so that those signals are recognized in that block and they are not recognized in the remaining part of the architecture. Okay, so this is the syntax of the block statement. Okay, this is one block. Okay, so the block is probe is equal to 1, then this is the begin and end of that particular block, and here you are going to define signal assignment statement which is there in the block, that is Z is assigned guarded not A. Okay, so this is what is assigned to Z, and you are making a block with that particular statement. Okay. Then you have the concurrent assertion statement. Okay, so assert statement is there in the data flow also. So this particular statement is used whenever you want to report any errors. Okay, so that time you can you can use this particular statement. The syntax is very similar to that of the statement which is used in the behavioral modeling. Okay, so you need to use the assert, and followed by that you need to have the condition. If that condition is satisfied, then it will send this particular message. It will report with this. Okay, or you can specify the severity also, which is error. Okay, so less often it is used, or if it is used in particular application. Okay, so this is what is there in the data flow modeling. Okay, so the major statements, they are, even the block statement is also used less. What you need to remember is the selected signal assignment statement. Okay, and another one is the conditional signal assignment statement. So these are the two major statements, the data flow modeling. So once you understand this, these two statements, okay, then you can. There is no problem writing the program in the data flow modeling. Okay. I give you two examples now to write the program. In the next class, I shall ask you to present this particular program. Okay. All of you are having notebooks with you, so take this particular program. Write a VHDL program using data flow model. Write a VHDL program using data flow model for 4-bit binary adder. 4-bit binary adder. Earlier you have written program for a full adder. Now it is for the 4-bit binary adder. That is the first program. The second program, write an VHDL program using data flow modeling. Using data flow modeling for BCD to XS3 converter. BCD to XS3 converter. Okay, so I have given you 2 assignments. These 2 assignments are very simple assignments, and you need to write the program, VHDL program. So I expect that in the next class, all of you will have this particular programs ready either in your laptop or in your mobile. And as I ask anyone, anyone should be able to present this particular program. Okay. I hope all of you have marked your attendance. It is now time to go to the next class. If you are not marked your attendance, you have 2 minutes more to mark your attendance, and you can switch to the next class. Okay. So bye and have a good day.
Thank you, sir.
Okay. Thank you. All of you may leave the meeting so that the meeting will end. Otherwise, the recording will continue. Yes, hurry up, student. Leave. Sonali, Nikita, Sanket, Hikal, Shubham, Anjali, Bangi, Rohit, Saurabh, Prashant, Rishikesh, Tejas, Siddesh, Vaishnavi, Pawar. Nikita, are you not there?